Good afternoon for the third time, Howard Wig, Code Green. My guests today are Sam Monet, Managing Partner of Plug and Play Energy Systems, has to do with batteries, and Mark Want, my colleague in the State Energy Office. He is the, how about civil defense guru? That sounds pretty good.
Or more typically, energy emergency planning analyst.
That's what I was trying to avoid there. Yes. So we've only got 15 more minutes, so why don't we need to wrap things up? I think you have some examples of, here's the hurricane.
Well, this screen first shows what happened last summer.
Mm-hmm.
Lots of tropical storms and depressions and a few hurricanes.
Mm-hmm.
And what the really frightening part is that they're all going north of us when they used to go south, okay? And even with the El Nino global warming is going to create that environment for a long, long time. As a surfer, I mean, there were some days I paddled out and the water was so warm I was getting exhausted in the water just from paddling the heat. Records, it's around 3 to 5 degrees, was 3 to 5 degrees warmer this summer. And we had 50 record-breaking heat days around the state. So for all of those folks out there who think it's not happening, you need to take a look. As a surfer, I see it, and as a sailor, I see the wind problems. And
Mark, maybe you can explain the correlation between warm water and hurricane generation?
No, not exactly. But actually, warmer water actually aids in the development of tropical cyclones. So it's one of the components. You need a certain amount of wind, certain ocean temperatures, a certain amount of moisture. But yes, the warmer temperatures actually, like was mentioned, that allow these systems to move into latitudes up toward Hawaii closer, and you see even later in the season, so the season will tend to stretch out more. There'll be more systems coming through, but I'm not a meteorologist.
But there is that correlation. I remember being in South Florida at a beach, and I went into the ocean, and I said, God, am I in a bathtub or in a sea? It's so much warmer than it is here in Hawaii.
One of the thresholds is about 85 degrees Fahrenheit. So there are a lot of sites on the internet that'll show you how hurricanes develop, and it's really kind of neat to see. Anyway, they're frightening, and they're not the kind of things you want coming over your home. So here, this is Makaha. This is the existing substation at Makaha.
And you might explain what a substation is.
Right, a substation is where Hawaiian, if you looked at the first graphic that we had on there with a dumb grid, well, not this one, but there was a dumb grid graphic where it showed substations and 138 kilovolt power lines, et cetera. Well, this is one of the substations where power comes in from Hawaiian Electric, it comes here and it gets dispersed into the neighborhood. You have transformers and things like that that step down the power. But anyway, so here are some slides of some substations. This is the one out in Haleiwa. What we would like to do is we'd like to put about 4 of our batteries out there to smooth the wind energy that's coming out of Kahuku. All right, and then redistributing that energy back into the Haleiwa and the North Shore community. So there's so much room out there at this brand new substation. I mean, we'd love to have the opportunity to do what the wind companies were supposed to do, is put battery storage onto their systems. So we'd like to do that one. This one here is Lagoon Drive. Again, another substation that there's a lot of room there to put our batteries too. And if you have a battery storage at Lagoon Drive, all of the street lights and water pumping stations and everything else that are connected with the utilities and public safety in the airport area would also be functioning off of our battery storage system. So I'm just showing you that right now there's plenty of room on the existing grid at the substations to put our batteries in there. They're safe, they're reliable, they're tested. Our energy cloud systems have all been vetted. Our smart meters are all done. And so this one here is out in Waihiwa. Okay, so Waihiwa is in the middle of the island. They'll be one of the last people to get power too. And so there's plenty of room right there at the Waihiwa substation to put in battery storage. So there's no excuse for it. Here's Evanui. Hawaiian Electric put out an RFP for 200 megawatts of battery storage. We responded, and to our surprise, they gave the contract to another company that only came in with an 80 megawatt solution. And they haven't really finalized things yet. I think there's a problem with some of the safety issues in their batteries, but we could put in 80 megawatts right on this site right here tomorrow. So that would take care of that problem in the Eva Plain and with very quickly and easily. So unfortunately, we didn't have a chance to do that one. Here, this is Honeywell. This is in Manoa next to the University of Hawaii. We like this one. This is kind of, there's not a lot of room yet there, but we could stack 2 units in there because our batteries can be stacked. So we could get something in there. The next screen, I think the next one, okay, this is Iwalei, downtown Honolulu. We could put a few batteries in there, and that would help to power some of the systems in downtown in the case of a hurricane. Street lights, water pumps, and things like that, sewer systems, etc. So that's plenty of space available right there. And give us the contract and we'll do it. And then this is the one I like, Waikiki.
Yes.
The economic engine of the 50th state. And right here is a vacant lot in Waikiki that's been vacant for since day one. And this lot belongs to Hawaiian Electric. There's no substation in Waikiki. All of the transformers are located in some of the condominium buildings, and so when there's a shortage, the bills, elevators go down and things like that. But anyway, we think that we could put a substation right there in Waikiki and put some batteries in there, and in the event of a big problem like a hurricane, we could get Waikiki street lights, water running, public safety, police station, fire, and all of that. We could get that running.
And to emphasize again, water doesn't get from the ground up to the 36th floor of a hotel by magic.
Yeah,
it has
need
to be
power.
pumped up, and to pump it up, you need electrical power.
Well,
Yeah.
not only that, a lot of the hotels and some of the condominiums have diesel generators, but there's a study done by the fire department that indicates that in the event of a hurricane, all of the diesel on this island that's non-military will be gone in 2 days. So even if you have a diesel generator in your condominium or office building or your hotel, and you think that your elevators and pumps are going to be running for a month while they try to restore power to your grid, forget it. It's not going to happen.
Maybe
You're not
Mark
gonna get
can tell
power.
us what's happened to that diesel. How does it disappear so quickly?
Well, in a case of a hurricane, everybody sees it coming days out, and so a lot of people start hoarding and really sucks the supply chain dry. And so what you would normally have in a post-disaster, post-landfall, all that's been taken out of the system, and so it's a big catch-up, assuming that the tank farms at the refineries are intact, which is not not entirely certain because of the proximity toward the shoreline and other issues with flying object debris and everything like that. So remaining storage, it's going to take some time to get out to those locations to fill up those tanks. It's quite a complex supply chain, and it's made more difficult after a disaster because roads are blocked. People are screaming for it, and then that limited amount of fuel has to be prioritized. So it doesn't necessarily mean that everybody's going to be able to get a little bit. It's usually going to be going to, fire, police,
hospitals.
EMS, hospitals, pumping stations,
Yeah.
water, sewer.
Mhm.
And so it's a challenge. There's
Yeah.
just not enough fuel to go around. So having a backup source of power, is an advantage
Yeah,
in
yeah, yeah.
many respects.
Mhm.
So preparedness is key, having a resilient, robust system that can withstand a shock to the system
Right.
and then be able to come up very quickly after the event.
Like a battery.
Is what's needed.
Or a battery system. Yep.
We can't simply drive it in from California.
Mhm.
Okay, everything comes here by boat, and if the harbors are down, the power's down, you can't operate the big cranes.
And
all of those
we've
systems
got
fall
about
apart.
We've got about one more minute. Do we have any more slides too?
Well, I think the last
Oh,
slide we
no,
had was a really
yeah,
pretty
we
one.
exhausted the slide.
If you want to show that one again, it basically says that we're all in this together. Okay, and we all have to figure out ways to make our environment and safe and secure. And Hawaii, this is our home. It's our planet, but Hawaii's it's an island. It's like the planet Earth out there in space.
And if we have any, is this your pretty slide?
That's the one. I like that,
Yay!
yeah.
Oh, yes. Okay. And if we have a few seconds, just to emphasize again that these batteries can help smooth out the intermittent nature of solar,
Yeah.
because you have brilliant sunshine, then you have a cloud, then you have brilliant sunshine, then you have a cloud. The wind comes, the wind goes down.
Load leveling,
Yeah.
frequency regulation, all
Yeah.
of that stuff. Yeah, that's all part
Yeah.
of it.
And the batteries, when there's plenty of sun and the grid doesn't need it, the batteries can get stored up, and then they can feed back when it is needed. And
It smooths it.
ditto
It
with
smooths the power.
Yeah.
Yes, it does. You don't have all of the peaks and valleys that we saw in the graphic of the real-time energy
Yeah.
production.
And that saves Hawaiian Electric oil.
A
They
lot
don't
of,
have
well,
to-
yeah, wear and tear on the machinery too, because the machines don't like to be started and stopped and
Yeah,
jerked
yeah.
around like that a lot. So.
Yeah, just like a car prefers to be going
Yeah.
along at 40 miles an hour instead of, yeah.
And having worked on overhauling the turbines, and we're actually working on overhauling boiler tubes when I was a kid, the last thing you want to do is run that machinery into the ground. So, yeah.
So that's called resource efficiency.
Oh, nice. I
Yeah,
like that.
yeah. So again, as I demonstrated in the beginning, batteries are here. And what's my favorite slogan? The only thing that's changed is everything. The utilities know this very well. Batteries are going to be coming along they already are coming along like gangbusters. Not just here, but nationwide, indeed worldwide. And on that cheery note, we must bid fond farewell to Sam Monet, Mark Want. Thank you very much. Code Green, Think Tech Hawaii. See you in 2 weeks.